In this circuit, we have 3 resistors of different values connected in parallel. Why do we say they are connected in parallel? It's because all the resistors have common start and end points. Let's call the points X and Y. The fact that all 3 resistors have 2 common points or nodes should give us a hint. Is there anything we can deduce? Remember, potential difference is always measured between 2 points. If the 2 points are common, it means the potential difference across each of the resistors will be the same. If you look at the circuit carefully, you will notice that the points X and Y are common not only for each of the resistors but also for the battery. So if the potential difference across the battery is V volts, then the potential difference across each resistor will also be V volts. You can take a voltmeter and measure the potential difference across each resistor. You will see that if the battery has a potential difference of 5 volts, the potential difference across each resistor will also be 5 volts. What about the current across each resistor? Let's say the current flowing in the circuit is I. Then what will be the current flowing in the R1 branch? Let's connect the ammeter in that branch to find out. We take out the plug from the key and connect the ammeter in series with the resistor R1 as shown. Let the ammeter reading be I1 amperes. Similarly, we measure currents I2 and I3 in the second and the third branches respectively. After measuring the individual currents, we get a relation between I and the currents flowing across the resistors. The total current is equal to the sum of the separate currents through each of the resistors. What is it that we're really looking for? Yes, what we're really interested in is the overall resistance of the combination of these resistors which are connected in parallel. Let's call the overall resistance Rp. According to the Ohm's law, the current I in the circuit will be the potential difference V over the combined resistance Rp. Now all we need to do is apply the Ohm's law to each of these resistors. For the first resistor, the current I1 will equal the potential difference V over the resistance R1. Don't forget, the potential differences across each resistor is constant. Now can you apply the Ohm's law to the second and the third resistors? You should have got these 2 equations. There's nothing special we did here. First, we applied the Ohm's law to the entire circuit and then to each resistor. Now we can substitute the values of I, I1, I2 and I3 in the first equations to get this. Dividing both sides by V, we get a relation between the overall resistance and the individual resistances. This is a very important relation. How can we understand it? We can say that when resistors are connected in parallel, the reciprocal of the equivalent resistance is equal to the sum of the reciprocals of the individual resistances. That's the concept of resistors connected in parallel. Though it's not very evident in this formula, but the overall resistance decreases when the resistors are connected in parallel. We will understand it better when we see an example in the next lesson.